Right, let's look at the first question. So what is common in the first term that's also present in the second term? So when I'm talking about terms, this is your first term, that's your second term. So what's common in both of those terms that I can factor out?
A.
Perfect.
A,
So
ma'am.
I factor out A, then I'm going to be left with P plus C. There we go. We factorized it completely. So the way these questions will be set up, they'll ask you to factorize the following completely, if possible. So the second one we're going to look at is PQ minus PM minus P. All right. So how many terms do we have this time? This time we have 1, 2, 3 terms. In those 3 terms, what is common in all 3 terms that I can factor out? So remember, when you factor out something, you have to make sure that whatever is left in the brackets has to match the number of terms you had originally. Okay, so let's see what's common that we can factor out.
P.
P.
Perfect. So we factor out our P. We're going to be left with Q minus M. Then what's the last term? Who can tell me what the last term is going to be?
-1.
Brilliant. Well done. Okay. Right. So these are the...
Ma'am.
Yes, Annie.
Ma'am, why is it -1?
Okay. So remember previously we've done what we call distribution. So when I want to check if my answer is correct, I would have to distribute everything.
Oh, I see, ma'am.
Right. So distribute everything back in to make sure you get what you had originally. Okay.
Yes, ma'am.
Awesome. All right. So on to something a bit different. A to the power of 6, a to the power of 5 minus a squared b. Okay, so again, we have 3 terms. Now, when we want to factorize these types of questions, we want to look at what's the highest power that's common, okay, or highest exponent that's common in all 3 terms. Okay, so whatever power or whatever exponent you choose has to be present in the first term, second term, and third term. So looking at this one, which term can I factor out?
A squared.
Well done, a squared. So since I factor out a squared, what would I have to multiply a squared by to give me what we had originally, which was a to the power of 6?
A to the power of 4.
Well done. Then in the second term, that would be a to the power of
3.
3.
Well done. Awesome. And the last one, we're going to be left with
B.
Brilliant. Okay. Awesome. Okay. Now, number 4. This time we have 15 DE plus 10 EF. Okay. Again, I want to factorize completely. So whatever term I choose or whatever variable I choose to factor out, I have to make sure that I've factorized it completely. So let's look at the coefficients first, 15 and 10. What's common to both 15 and 10 that I can factor out?
5.
5. And then in terms of the variables, what variable can I factor out?
E.
E, awesome. So 5E multiplied by what will give me 15DE?
3D.
Well done. And the last term, that would be?
2F.
Brilliant. Well done. Okay. Now, let's kick it up a notch, right? So let's look at this one. 4a to the 3 b squared c minus 8 a squared b to the 4 plus 12 a squared d. Right. What should I factor out here? So Ian, you've been quiet. Ian, tell me, what should I factor out, love? Let's think of the coefficients first.
4
Okay, 4, right? Then let's think of the variables. Which variable, we'll go step by step. Which variable is common to all 3 terms?
A squared.
A squared.
Yeah, well done. So now I factored out 4a squared. What will I be left with? First term,
B squared C.
okay. You're right, but there's something else. Remember, I factored out a squared.
Oh yeah.
A,
So
right?
AB squared.
Well done. Okay. Now the second term. Tamia, tell me, second term, what's going to be left there?
Oh, ma'am, I think it's AB to the power of 4.
Okay, so let's check, right? So we remember we took out.
Oh, it's 2. Sorry.
Yeah. Okay. So -2. Okay.
2.
And then, so we took out a squared. Then what's the other variable that's left over here?
B4.
Well done. Okay. And Ryan, the last term, what do you think?
Plus 3D.
Well done. Plus 3D. Well done. Awesome. Now let's go on to what we call a difference of 2 squares. Okay. Now remember, difference of 2 squares, dots. Okay. When you have a perfect square, such as a squared minus b squared, these are 2 squares, and the minus, remember, that's just a difference. Okay. So to factorize dots or difference of 2 squares, I would have 2 brackets. The first one is a minus b, and the second one is a plus b. Okay, so let's say this time we had the number 9 minus m squared. Okay, 9 is a perfect square. How would I factorize this one? So let's think of the number 9, right? What's the square root of the number 9? Another way of thinking of, yeah, perfect. So we're going to plug in 3 there and 3 there. Then the square root. So let's look at the pattern above, right? So the first bracket had a negative or minus, and then the second one plus. So that means also here, I'm going to have minus and I'm going to have plus. Then m squared. What's the square root of m squared?
M.
Perfect. So 3 minus m, 3 plus m. That is how we factorize this one. Awesome. Then this is also an example of a difference of 2 squares. Okay. Right. So for this one, again, same process, right? You're going to have your 2 brackets. And then let's think about the 16x squared. If I were to take the square root of 16x squared, what's the first term I should put in the first position in both brackets?
4x.
Well done.
4x.
And 4x. Then we know that one's going to have minus, the other one's going to have plus. And square root of y squared is just y.
Y, ma'am.
There we go. Awesome. All right. Okay, let's do something where you're going to have to apply your minds a little bit further. Okay, so now 49b squared minus 25c squared. Okay. Let's factorize this one. Okay, it's also a difference of 2 squares. Okay, you have to think about, okay, is 49 a perfect square? Yes, it is.
Yes.
Okay, so square root of 49b squared, what would that be?
7b.
7b.
Well done, 7b. One's negative, one's positive. Then 25c squared, that's also an example of a perfect square, okay? Square root of 25c squared. What would that be?
5C.
5C.
Well done. Awesome. Okay, now let's think about this one. I'm going to throw a spanner in the works. Okay. Okay. Would you be able to factorize this type of question? If you think so,
Yes, ma'am.
okay. So why do you think you would be able to factorize it? Let's think about it. Remember what we've been learning so far. This is a difference. Okay. So this is a difference. Okay. Of two squares. What was the thing? The key word here was difference of two squares. Looking at number 9, do we have difference?
Yes, ma'am.
No.
No, we don't. Why? Because look,
Is it?
this is a plus sign.
Oh,
Right. So that was the trick there. Okay. So the trick was that we had a plus sign here. If you have a plus sign, you can't factorize it using difference of two squares. So the difference of two squares only applies when you have the minus sign.
minus.
Right. So subtraction. So if it looks like this, then you'd be able to factorize it. So let's go ahead and factorize this one. We know it's going to be.
X.
Mm-hmm.
And then the square root of 9 is 3y.
Well done. So minus 3y plus 3y. Well done. Awesome. Okay. Now let's look at this one. M to the power of 4 minus 1. Okay. Right. Now we're moving on to higher powers, right? So when you have an even power, so like if it's x squared or x to the power of 4 or x to the power of 6, those are all even powers and you can find the square root of those even powers. Okay, so how would I factorize this one? This is also a difference of two squares because the number 1 is actually a perfect square. Okay, so ideas. Okay, we want to find how we would factorize this one. How am I going to factorize this type of question?
M squared.
Yeah, well done. M squared.
Plus 1 and the other bracket minus 1.
Well done. Okay. Now, remember the idea is to factorize completely, right? So, is there still something we can do here? Have I spelled this correctly? I don't think so. How do you spell completely? I think I was correct.
Yes,
I
you were
think
correct, ma'am.
Okay.
You are correct.
All right. How do we factorize? Is there anything else here that I can factorize?
Yes.
Yeah. What is it? What can I still factorize?
M squared minus 1.
Brilliant. Okay. I can still factorize this further. So when they say factorize completely, you have to check if your final answer is actually completely factorized. I can go a step further. M squared plus 1. That one stays the same. We can't factorize it any further. But the second bracket we can. It becomes M minus 1 and M plus 1. Well done. Brilliant. Now let's combine the two things we've learned today, right? So let us look at this question. Okay. 12p squared minus 75a squared. Okay. So we're combining the two things that we learned today. What's common in the first term that's also there in the second term?
Three.
3. Awesome. So I factor out 3, then I'll be left with 4p squared minus 25a squared. Okay. Are we done factorizing?
No.
No,
No,
because
ma'am.
we can still factorize what's inside the brackets. This is a difference of 2 squares. Okay, let's see. The 4p squared minus 25a squared, what does that become when I factorize it?
2p
Mm-hmm.
Oh yeah, I still
plus
have them.
Okay, plus, and then one's minus. Yep.
5a.
Well done. Well done. Brilliant.
Ma'am, why is it 2p minus 5a?
Oh, okay. Let me explain that quickly. So remember previously we're doing what we call dots, right? That's a difference of 2 squares. We look at the
Yes, ma'am.
first term, right? And we ask ourselves, is this a perfect square, right? Remember a perfect square, you can take the square root off. So the number 4, what's the square root of the number 4? It is 2, right? And
Yes.
then p squared, if we take the square root of p squared, it would be p. So that's why for the first term, it's 2p. And then this is a difference of 2 squares. This is also a perfect square here. If I take,
Oh, I see, ma'am.
right,
I see.
good.
I see, ma'am. Because
Oh.
Mhm.
Okay, awesome. Right, now let's see. X to the power of 3 minus x squared. How would I factorize this one?
I don't think you can, ma'am. Or can you?
You tell me. You tell me.
I
Let's see.
don't think so.
Okay, but let's start by doing what we did at the beginning, right? Let's look at the first term, then look at the second term. Is there a variable, okay, that's common in the first term that's also there in the second term?
X squared.
Right,
Yes, ma'am.
x squared. So if I take out x squared, then I'll be left with x minus
The power
1.
Oh, 1.
Yeah, so it's x to the power of 1. You can just leave it as x and x minus 1. Right. So looking at this, okay, we can't factorize this further. Why? Because you have an odd power here. So you can only factorize it further if it was an even power. So for this one, there's no need to do difference of 2 squares. Your final answer would just be x squared, then open brackets, x minus 1. Okay. All right. Now I'm going to do one of our last questions. A plus b squared minus c squared. So now this question is actually a difference of 2 squares. Okay. Now they could ask you, how many terms do you have here in number 13? How many terms?
2.
2.
It's 2. Yeah, 2.
2, right? Okay, so it's going to be 2, right? Because remember,
The
brackets,
brackets.
yeah, brackets combine terms. So this becomes 1 term, and this is your second term. Right. So is the first term a perfect square? Yes, it is. You have an even power. Second term, is it a perfect square? Yes, it's a perfect square. So you would be able to factorize it using the difference of 2 squares method. The difference is that, okay, when you take the square root, okay, of the first term, right, all you're going to be left with is a plus b there and a plus b here. Then remember the first one, minus plus. Square root of c squared, okay, that is just c, and this one is c, okay. This one was a little more complicated, okay. Now let's do another one, okay? Similar, so I'm gonna say p plus q squared minus 4. How would I factorize that one?
P plus Q
P
minus
plus
2.
q. And carry on, love.
P plus Q plus 2.
Well done. Brilliant. Awesome. Sure, guys, you guys are amazing. Okay, now, oh, I'm making them harder. Okay, now let's look at this one. Now I've got 25 there. Then I've got x plus y squared. Then I have minus 100. Oh my goodness. Okay. Do we have a difference of 2 squares? Right. Okay, so we always look and see, okay, let's look at the coefficient. The number 25, is that a perfect square? Yes, it is.
Yes.
Okay, so that means I can find the square root of the 25 here. Square root of 25 is what?
5.
5.
Right. Then can I find the square root of the x plus y in brackets squared? What would that be?
X plus y.
Well done.
Excellent.
Then can I find the square root of 100?
Yes.
What is it?
10.
Well done. Okay, so this is my first bracket. Oh gosh, then second bracket, the first term is the same and plus 10